Alright, this first question asks us to find an equation for the tangent to the curve at a given point, and we have y equals 16 square root of x, and our point is 432. So I know if I want to find an equation tangent, then I'm going to need my y minus y1 equals m times x minus x1, where I already have my x1 and y1. I just need my slope, and to find the slope I just simply take the derivative of 16 to the square root of x. So I can pull that 16 out front, and then the derivative of square root of x is 1 over 2 square roots of x. So that becomes 8, and I can also plug in my value for x. So I get 8 over square root of 4, or 8 over 2, or my slope equals 4. So now all I have to do is just plug all these values into this equation. So y minus y1, which is 32, equals my slope, which I just found, and then times x minus my value of x1. And I mean, you could solve it for y if you want to, and you'd get 4x plus 16. Alright, so in question 2, it asks you to calculate, on part A, to calculate the derivative for f of x equals 5x plus 9. Well, the derivative of 5x would be 5, and the derivative of 9, a constant, would be 0. And then it said to give the value of the derivative at x equals 2. Well, because this is a constant, then the value would just be that constant. Part B, we're given f of x equals 5x plus 3 over x. So the derivative of 5x, again, would be 5. The derivative of this one probably would be easier to write like that. And so you would see you'd bring the minus 1 down. So you'd have negative 3 to the x to the minus 2. Well, I'm going to go ahead and throw that on the bottom. And then the second part is to evaluate it at negative 2. So I simply plug in a negative 2. And I get 5 minus 3 fourths, or 17 over 4. Alright, question number 3. Here is part A, is to find the first and second derivative for y equals 6x to the 5th over 5 minus 3x plus 8e to the x. Well, the first derivative, I would bring the 5 down, so I'm going to just put that 6 out front. I would bring the 5 down and then subtract 1. And then the second derivative, I would just have negative 3. And then if I bring the 8 out front, remember e to the x, the derivative is e to the x. So as you can see, that cancels. and I end up with my first derivative equaling 6x to the fourth minus 3 plus 8e to the x. I want to take the second derivative, so I bring the 4 down, so 6 times 4 is 24, subtract 1, the constant, negative 3, becomes 0, and then plus, bring the 8 out front, the derivative of e to the x is just e to the x. Alright, here is part B of question number 3, where we want to find the first and second derivative for this equation. Now my only comment on this is some of you tried to bring the 4 and the 5 to the top, and you can't do that because this is really written, I could rewrite it like this. And so the only part that you can bring to the top are the s's. So that's how you can rewrite this as s to the negative 3 over 4, and then minus 6s to the negative 4 over 5. But some of you guys tried to bring the 4's and the 5's to the top, and that's kind of what got you in trouble. Alright, so now if I take the derivative, I just bring down negative 3. I subtract 1, leave the bottom alone. Here I'm going to bring down a negative 4, so that negative 4 and that negative sign make a positive 24. Subtract 1. And I could make this look a little better. Minus 3s to the negative 4 over 4. Oops, sorry. I said make it look a little better and I didn't change anything. Meaning I could rewrite this with the exponents on the bottom. Wasn't necessary, but just something that if you wanted to, you could have written this way. So either way. So now I want to find the second derivative. And when I find the second derivative, I probably would want to look at this one because it'd make it a little easier. So I bring down the negative 4 and a negative 3 is a positive 12. Subtract 1. Bring down the negative 5 times 24, so 120. Subtract 1. And once again, I could write this first one as 3, because this of course would become 3 over s to the 5th. I'm just bringing the exponents to the bottom, and then minus, that actually cancels to become 24 s to the 6th. Alright, so here is question number 3. This is part C. So we want to find this first and second derivative. What I probably would have done is went ahead and distributed and multiplied all this out, meaning you would have ended up with 3x cubed minus 12x plus 3 minus x to the 5th. Remember, when you multiply same basis, you add the exponents, plus 4x to the 3rd minus x squared. I can collect some like terms and maybe even put this in order of exponents. So I have minus x to the 5th plus 7x to the 3rd minus x squared minus 12x plus 3. So now it's easy to go ahead and find the derivative. So I'd have minus 5x to the 4th, I brought the 5 down, subtracted 1, plus 3 times 7, 21x squared, minus 2x, minus 12. Of course the 3 is a constant, so that goes away. Then the second derivative, 4 times negative 5 would be negative 20, subtract 1. 21 times 2 would be 42, subtract 1, and then minus 2.